Hello, I hope you are all doing well. Right now, I'm going to explain the first law of thermodynamics, which really is just energy conservation. Energy conservation. Uh, and so, moving on to that, what are the types of energy that we're going to be looking at? We are going to be looking at U, which in this case is internal energy. We're looking at W, which is work. And we're going to be looking at Q, which is the heat of the system. And since this is all energy, this is all going to be in dimensions of joules. And this is going to be where the change of the internal energy is the heat plus the work, or this is where this law gets very fun, is equal to the heat minus the work. Now, why is there a change of sign? We will talk more about this as this goes on. But essentially, this is work on the system. And this is going to be work by the system. It's a bit of a weird concept, but essentially this is adding energy. This is when it is losing energy. But we will get further into this. So let's look at U, Q, and the work. So first off, the work. So first off, work done on a system is equal to the negative of the work done by the system. Now, let's talk a bit more about work. So we know that work is equal to force times distance. But we also know that force or pressure is equal to force over area. So if we throw that to the other side, we know that force is equal to pressure times the area times the distance. Area is x times y. In this case, the distance is going to be in the z direction. So we know that this is in 3 dimensions. So this is really just pressure times volume. Or what we can say is work is equal to pressure times the change in volume. For B, we're going to be looking at change of energy or internal energy. Now, this comes from like moving, rotations, oscillations, and like chemical bonds, and more. Essentially, it is like all of this packed together is the internal energy. You could see this because of diatomic bonds like rotating or they're moving around. Essentially, it's like the kinetic and the like potential energies all combined. This concept will actually become much more important as we go on, because when we were looking at ideal gases, the ideal gases isn't going to be looking at like the potential energy within the internal system, really only the kinetic energy, which is very useful, which is pretty interesting and something we'll talk more about. And as for the heat of the system, Q is equal to the mass times the specific heat capacity of whatever the material is times the change in T. So heat is kind of like a function of temperature in a way. And to talk a bit further about this, if we say that we have some type of like cylinder per se, this, some type of here. So pushing this down, we see that we have a force, or we can also say pressure, where pressure is the, of course, force per unit area. And this is going to be some type of distance d. So talking more about this, if we are doing work on the system, aka we are pushing from the environment down into whatever this system is, which is going to be a change of, some type of volume, by pressing on the work, so doing work on the gas, we are in fact adding energy, because as the particles are moving about, by pushing on, we are making the particles essentially inside the system move faster. Well, if the work is being done by the gas, aka the stuff inside here, all of this is moving up, we are losing energy, and the volume will increase, aka the work from that. Now, let's just say as well that's work. Let's just say we have some type of heating pad or something. Who knows? So it's hot over here. And we have it moving up into here. What does this mean? Well, we have heat going from the environment into the system. So heat is being absorbed into the system. That would mean that energy inside the system is increasing. Whereas if we were having heat leave the system, right here, it is in fact losing energy. So that is negative Q. For a little demonstration. And let's just put this down. So change of view be equal to Q plus P times the change of volume. Just because we know that work is pressure times volume, which the volume gives us a bit more, is pretty helpful in visualizing what's happening with this work. But I was talking a lot about whether the work is done by the system, whether it's done on the system. So we should look at, the signs, whether it's positive and negative sign. So with this is sometimes a bit confusing, frankly. Even when I was looking at this, I wanted to make sure that I was doing this correctly. And it sometimes is a bit hard because textbooks will say either by the system, on the system. Frankly, sometimes it seems like they contradict themselves a bit too, to make this even more confusing. But to try to get the best demonstration possible, let's say that it is looking specifically at heat right now. So this is from the system and it is moving to the environment. So in this case, we are looking at this. So we have the heat within the system and it is leaving said system, going to the environment. Therefore, then we are looking at heat being released. So that is so we are losing heat. So it's negative because it's being released. Well, if we have the environment in here, and is going to the system, then we have heat from the environment, for example right here, it's going into the system, that's adding energy, then that is plus heat, increasing the heat, this is being absorbed right here. Now, what does this mean though? If, for example, we go from the system to the environment, back again, well, that means that the system is expanding, potentially. If it's expanding, it's losing energy. So we're looking at negative work because this is being done by the system. right here. So the work is being done by the system. Volume is potentially increasing, is losing energy, is expanding right here. While for this one, opposite, if it is being done from the environment onto the system, aka it's like this piston right here, is pushing on the system, the area inside is, the volume is compressing, because it is compressing, energy is being added into the system. Because volume is decreasing, that's going to speed up the particles with inside the system. So the work is actually increasing, and because this is done on the system. So again, by the system is when it is, again, from the system going to the environment, acting on the environment, while when it is on the system, it is the environment acting on the system. It can be a bit weird. This would mean that it's compressing, but it is something that is really important to try to wrap your head around, as this is a really important concept within thermodynamics. And by having an idea of whether the work is being like by the system, whether it's on the system, will really help you out when whether you need to make a positive or negative sign. That will change whether the answer for what's going on, and will also change what the system is physically means, or what it's physically doing. So let's look at some energy scenarios right now. So first case, let's look at what happens if the work is equal to 0. aka we have like a constant volume. So V is constant. Well, then that would mean that the internal energy is equal to the heat. Again, whether it is leaving or entering the system depends on whatever the problem you're looking at. But that would mean that energy, that would mean that any change of energy is from heat transfer. Okay? So it means all the energy that's happening in the system is from heat transfer. So like, for example, if it was only this hot plate, volume was constant, and was being added into the system. Next scenario, let's look at what happens if the heat is 0. So this would mean that it is adiabatic. We talked a bit about this before in the previous video, but that is essentially mean that heat is 0. Well, what does this mean? This means that the change of U is really equal to the work. Now, remember, for work done by the system, this is expanding. While for this one, right here, this is done on the system. Right here, so it is compressing. I keep bringing this up because this is a very important concept to know whether it's on or by the system. And this would mean that whatever is the internal energy of the system is used only strictly for work. So in this case, it would be like this heat right here does not exist. All the internal energy is essentially moving the volume up or down, for example. And now let's look at what happens if the internal energy is equal to 0. Now this would be an isothermal system, which means that T is equal to constant. But this is only for ideal gas. So I'm going to have to put an asterisk here. Ideal gas. Why? Because the gas is we're only looking at the kinetic portion, not really the potential, because just because is isothermal, aka the temperature is constant, doesn't mean that the internal energy is constant, unless we're talking about like an ideal gas. But what does this mean though? Regardless as to the system, whether it's isothermal or not, ideal or not, well, that would mean that Q is equal to the work, aka the amount of heat that you're putting into the system only makes work. So that would be like if we, I don't know, for example, are adding heat into the system here and the volume is increasing, and there's no weirdness happening in the internal energy. So like there's no rotational like diatomic particles within, so like the diatomic atoms within the system aren't like rotating more, so on and so forth. So it's like the heat is directly proportional to the work that is happening. So then heat transfer is used completely for work. Okay. And then going back to 5, as you probably have known, we're talking about whether it goes in or out. However, at the end of the day, this is all just conservation of energy. All of this. So this is not a new law. This is not anything profound. This is just conservation of energy. So wherever the energy is initially has to equal the X amount of energy in its final condition. Things will change in between. The energy will go to different places. However, the energy from input to output is the same. It's just conservation of energy. And with that, thank you for watching. Please let me know if I made any mistakes, especially when it comes to these positive and negative signs. But thank you so much for watching, and